Welcome back. Today I'm going to be talking about definite integrals, and we're going to be doing 5 multiple choice examples. The first one asks us to evaluate this integral here from the bounds 0 to 2. And so basically what this is representing is what's the area under the curve, or I should say the net area of this function between 0 and 2. So first I'm going to take the integral as I normally would. So we're going to end up getting x cubed, right? Because the antiderivative of 3x squared would be x cubed, just using power rule. Then for negative 2x, we would get negative x squared, because recall that derivative of x or of negative x squared is negative 2x. And then for 1, we'll get x. And then we're going to have the bounds of 0 to 2 for this. Now, a lot of people ask, oh, but what about plus c? Don't you have to include plus c? And here's the reason I'm not including plus c here. It's because although there could be a plus c, that doesn't actually make a difference here, because when we do our subtracting, right, because we're about to do f of 2 minus f of 0, we would end up with plus c and then minus c if we did have the plus c, and so therefore there's no need to include it because it would just get canceled out anyways. Okay, so now I'm going to evaluate it by first plugging in 2 and then subtracting, plugging in 0. So 2 cubed minus 2 squared plus 2, and then minus 0 cubed minus 0 squared plus 0. The first part here would be 8 minus 4 plus 2. The second part would just be 0. And then 8 minus 4 plus 2 is 6. And so the correct answer here would be 6. All right, now let's try a second one. So same steps here, but this one looks a little bit different because we have 1 over x. So recall that the antiderivative of 1 over x is ln x, or a natural logarithm. So therefore, this is equal to ln x from e to 1, or from 1 to e, I should say, because 1 is smaller than e. Then we're going to get ln absolute value e minus ln absolute value 1 when we plug that in. And then ln e just cancels. And we just end up with 1, right? Because ln and e cancel, we get 1. And then what's ln of 1? Well, recall that ln is just natural logarithm, right? Logarithm with base e. So e to the power of what would give us 1? Well, 0. E to the power 0 gives us 1 because anything other than 0 itself to the power of 0 gives us 1. So 0 would go here. And so the final answer is 1 minus 0, which is 1. All right, here's another one. So same steps. First off, what is the antiderivative of cosine? Well, that'd be sine. So therefore, this is the same as sine x with the bounds from 0 to pi over 2. And then I'm going to plug those in. So we're going to get sine of pi over 2 minus sine of 0. And then what's sine of pi over 2? Well, if we think about the graph of sine, how it goes like this, we would remember that sine of pi over 2 is 1. And then sine of 0 is 0. Okay, so 1 minus 0, which once again is 1. And so that's our answer. All right, and here's a third example. So first things first, let's find the antiderivative of each part. So the antiderivative of x cubed would be x to the power 4 over 4. The antiderivative of 2x is x squared. And we have to evaluate that from 1, or from negative 1 to 1. Okay, so then we'll sub in 1 first. So 1 to the power 4 over 4 plus 1 squared minus negative 1 to the power 4 over 4 plus negative 1 squared. And then that is just going to equal to 1/4 plus 1, which is 1 1/4. And then here we're also going to get 1 1/4 again, so minus 1 1/4, which is going to just give us 0. So the answer for this one is 0. Now you might be thinking, oh, but how is an area going to be 0? But keep in mind, it's the net area, not like just the general area. And so let's say, for example, it's symmetric. Like let's say it's something like, I'm just making something up, but let's say it was something like this, for instance. where these two were the same, and we had from like here to here, for example, assuming these two are the same, because this is below the x-axis, this one is going to cancel out the one that's positive, right? So it does net area. It does any area above minus any area below, right? And so that's what the net area is. And so basically they're saying whatever areas there are would just cancel there in this particular scenario. And if you're curious of what this one in specific looks like, because it does look a bit different from what I just drew, I just kind of drew a general example for that to demonstrate that idea. Feel free to plug that into Desmos and take a look and notice how the net area would cancel in this example too. And that's why we get 0. All right, one last question. The value of the integral from 0 to 4 of the square root of 16 minus x squared dx represents which of the following? So here's the thing about this. Our function here would be y is equal to the square root of 16 minus x squared. If we rearrange this, right, if we square both sides, we get that y squared is equal to 16 minus x squared. And then if we add x squared to both sides, we get x squared plus y squared is equal to 16. And recall that this is just the formula for a circle that has radius of root 16, which is 4. So a circle of radius 4 that has the center at the origin. That is what this equation is representing. And so basically what they would like is they would like from 0 to 4, what is the area, right? So not the full thing, because the full thing would be from -4 up to +4. They would like to know from 0 to 4, what would the net area be there? So automatically there, if it's going to be from 0 to 4, because keep in mind these are the bounds for x, not the bounds for y, it must be the right side of the circle, right? So if I have this circle like this, it's got to be the right side, just the right side parts of the circle. Now, the thing is, it's not going to be the full semicircle though, like it looks like, right? Notice that we just have 16 minus x squared, which is going to just be, this is just going to give the positive values. And so it would actually just be the area of the quarter circle with radius 4. It would just be this upper right quarter circle here. And so the final answer is B. Now, as always, if you have any questions, feel free to leave those down in the comment section, and we'll see you for the next one.